Hello everyone, welcome to my YouTube channel. In this video, I'll be explaining a C++ program that converts a binary number into its decimal equivalent. But before writing a code, we need to understand the logic behind the program. A binary number is made up of just zeros and ones, and that is what runs binaries. So to convert it to a decimal, we need to multiply each binary digit by its corresponding power of 2 and add the values together. But before we jump into the code, we need to understand the foundation of every good program, the algorithm and the flowchart. Because before a programmer writes a code, they first need a plan. So we take the algorithm as a recipe. Before you cook a meal, we need to write down the instructions. So our algorithm is a step-by-step procedure used to solve a problem. And the algorithm is our instruction guide. So just as you can see on the screen, we have an example of an algorithm. It always starts with start and ends with an end. Then beside the algorithm is a flowchart. Flowchart is also just the graphical representation of the algorithm. Now we can move to our code. So first, we include the required libraries. Include IOStream, include IOStream, include string, include CMath. These are our libraries. Then the IOStream library is used to input and output. Then the string library allows us to store the binary number as text, and CMath provides mathematical function. The execution of our program begins inside the main function. That is why we wrote int main. Next, we declare a single variable called binary. We use a string because a binary number contains just zeros and ones. Now we ask the user to enter a binary number, and the value entered by the user is stored inside the binary variable. So the cout is enter a binary number. So when you are running the code, you see enter binary number and cin binary. So it allows you to input a binary number inside. After that, we create two integer variables, decimal and then the base. This is what we have there. So the decimal will hold the final converted value, while the base represents the power of 2. It starts at 1 because the rightmost digit in binary represents 2 raised to the power 0, and 2 raised to the power 0 is 1. Now we get to the main logic of the program, the for loop, and that is what we can see here. So the loop starts from the last digit of the binary number and moves backwards. We do this because binary conversion starts from the right side. For example, if the input is 1011, the program first looks at the last one. So inside the loop, we check whether the current digit is equal to 1, and that is what we can see at the if binary I is equal to 1. If the digit is 1, we add the current base value to the decimal variable. And then if the digit is 0, nothing is added because 0 does not contribute to the value. That's why we have what we have there. After checking each digit, we multiply the base by 2. That's why we have base equal to base times 2. This happens because binary numbers work with powers of 2. And the base values increase like 1, 2, 4, 8, 16, and so on because they are just powers of 2. Finally, after the conversion is complete, we display the decimal equivalent. That's why we are having cout. And the program then returns 0, which means it has successfully completed execution. So you write return 0. Without return 0, your program will not run. We enter 1011. Then we press enter to see what our answer will be. So our decimal equivalent is 11, which means it satisfies the program problem. Thank you for watching. Keep learning, keep coding. Don't forget to like, subscribe, and share. Bye.